All right, this is Mr. Wyrick, and today I'm going to go over the 3.8 notes, the lines tangent to a circle. So this is going to be a little different than the lines intersecting the circle. So hopefully you kind of catch on to the differences, and this should be hopefully a little bit easier. So as we're looking here at, I'm going through the slides one at a time. I'll tell you where I am. On slide number 2, how many times do lines and circles intersect? And then what are all the possibilities for intersecting lines and circles? So generally, there's 3 different ways that this can go. You can have your circle and you have your line going through the circle in some manner, and it intersects twice. Okay, that's what we did yesterday. We kind of saw, oh, hey, here's these 2 places where this line crosses this circle. Then you have your circle and you have your line that's outside of it. So they're never going to cross. There is no intersection point for that. But then the third one, and the one that we're going to talk about today, is that line that goes by and just touches the edge of the circle. So it only has one intersection point. It touches in one place. And if we look at slide number 3, you can see this. It says if a line intersects a circle exactly one time, it is said to be tangent to the circle, and the place where it intersects is called the point of tangency. So make sure to mark all of those down in the notes, okay? If it intersects one time, it's tangent. And this is where the tangent ratio for right triangles kind of comes from, but you don't get to make that connection until much later. So this isn't like we're taking opposite and adjacent sides and using that as a ratio. Okay, this is a tangent line to a circle. So we're touching right there. And you can see, if you look at it, it does create a 90-degree angle to that radius there. So we can see the beginnings of a right triangle. Okay, is there a way to place this sprinkler from where it is right now, here on slide number 4, in so that the sidewalk is tangent? Yes, we would just need to figure out like an exact point of tangency and kind of move our sprinkler to where it's just like that, and we're not watering the sidewalk. Okay, number 5. Finding tangent lines on the point of tangency can be easier. Think about having horizontal and vertical tangent lines for the circles. Okay, if I'm doing my equation of a circle, the easiest places to find the distance from the center based on that radius is either up, down, left, or right on those horizontal and vertical ones. So if I have a line that is horizontal, that is up just at y equals whatever it is, that would be above the circle or below the circle and touch in that one spot and have the point of tangency right there, you would notice those are perpendicular lines, and it is the distance of the radius away. Okay, slide number 6. The radius of a circle to the point of tangency is always perpendicular to that tangent line. They form a 90-degree angle. So for us, we need to remember, and it says on here, perpendicular lines have opposite reciprocal slopes. So when we start to look later on at our examples and your problems on the paper for today, if you're going from the center to that point of tangency and you go up 3 and over 4 or something like that, that's a slope of 3/4. So that tangent line would need to have the opposite reciprocal. We take that fraction, we flip it over, we change the sign. So if my slope of my radius was 3/4, my tangent line would be negative 4/3. Okay, flip it over to where it's 4/3, change the sign to a negative. Okay, and then slide number 7 here is reminding us about point slope form. So this is a pretty big deal. If we know what our slope needs to be, which we should, if we know the slope of the radius, we know the slope of that perpendicular line, and then we can write it in point slope form to make it go through that specific point and just stop with our equation written right there. We don't have to do any kind of calculation to find the y equals mx plus b, the slope intercept form of that line. Okay? And then slide number 8 has a sample problem on there. It says draw a line tangent to the circle whose equation is x minus 2 squared plus y squared is equal to 20 at the point 0, 4. Write an equation for that tangent line. So I'm going to show you this is what that's going to look like. So when I calculate this, I'm going up 1, 2, 3, 4, and backwards 1, 2. So that is a slope of down 2 over 1, down 2 over 1. That's a slope of negative 2. So if that's a slope of negative 2, my tangent line here is going to have a slope of positive 1/2. Okay, so this is going to be y minus 4 is equal to a positive 1/2 times x, and in this case I wouldn't necessarily have to put plus or minus 0. It's just going to be the x. Okay, so y minus 4 is equal to 1/2 x. So this should be enough to kind of guide you through your paper for today. I'm going to add a slide here on this one so that you'll see it when you're looking at it. This is today's assignment. And today's assignment is going to be the 3.8B worksheet. Okay. Now, I will actually have paper copies of this ready to go because I like you to have the graph and be able to kind of see what you're doing on that graph, but I'll also post it on Schoology so you have that with you. This should be enough to kind of get you through going through that. There's only 4 problems on there, so it should work relatively quick if you kind of understand what you're doing. If you take the notes and follow along and exhibit a little patience and work towards some understanding, you should get there, and hopefully this helps.